Hi everybody, Bill Sky, the Assembly Guy, with my last video on random file input and output. This one, output only, Windows. What does this mean? Well, once you find the data you want to update in a file with random reads, which was my previous video for both Windows and Linux, this one shows you how to just write out that one little piece of data, not have to rewrite anything, not have to read anything before or after it. You just update that one little piece of data randomly. Let's get coding. Okay, so I've got my Windows up here and running, and I have my Visual Studio project set up that we did from the previous video. Now, if you haven't watched that previous video, go to the description of this video, click on that link, take a look at it because you're going to need information there for it to make more sense here. So what I've done here is I've added some to-dos into my program. The first thing that we need to do is we need to create some new messages. What we're going to do is that we're going to have the user type in a value, a position in the file they want to read the data. And then after they read that data, we want to present them with a prompt, a message that says, hey, what is the value of the data you would like to update that read data to? So the way this will work is that the read pointer will move to the position in the file where you want to read the data. You'll read the data. Notice that the position pointer moved. You'll then reposition it to where that data began. You'll ask the user what's the new value you want to write to it. Then you'll write it over the old data. That's random file IO. Boy, I'm telling you, before this we used to have to read everything before the data we wanted to write. We'd have to read that and write it to a new file. We'd have to read the data we want to update it in the program, write it to the new file. Then we'd have to read everything after that data, write it to the new update file. Close both files, delete the first file, rename the second file to the name of the first file. Whoa. Random file IO is so much easier. So we want to ask that question. Now enter a new value for this position in the file. So we did that, so let's go ahead and get rid of that to do. And now let's scroll down. And I also have another value. I also have a couple of other variables that I created. New value and save file position. The new value is the value that the user enters, that they type in and is going to actually be stored in this variable to write to the file later. And then save file position, when we position that position pointer in the file to where we want to read the data, we want to save that data first. We want to save that position so we can use it when we're going to write it. So I created two quads, variables right there that we can use later on. Okay, so we're going to just scroll through all this code that we wrote in the previous video, and let's just jump down here. There's the read file, or the read code. Here we go. Here's to do number 2. So what to do number 2 says is ask the user for a new value. What has happened before this is that the user has typed in a position in the file to read. The pointer moves over to that position. We read the data and we display it. You can see that up here, that we've actually printed the number to the console that the user has found in the file. So now what we want to do is we want to ask the user what is the data, or what is the data that you would like to replace. Now you could do something else with this. You could say something like, do you want to update the data that we just displayed on the screen? And if they say no, then you could just skip around this code and ask them to type in another search value. But that's something that you can do. We're going to go ahead and just assume they want to update it. So what I'm going to do is I'm going to move into, RSI, the offset of our new value message. That was the string that we created up in the beginning. That was step number 1. We're going to push RSI, and then we're going to call print string. Whoops. Okay, and what that'll do is that will display the new value, or it will actually it'll display the new prompt asking the user to type in the new value. So let's go ahead and actually run that just to see how it's working. Okay, so let's put in 1. Okay, now enter a new value for this. Okay, great. And then it says please enter an integer because we didn't do anything after we printed off this new value here, or this new prompt. So let's go ahead and end that. And now let's continue. So we're going to ask the user for the new value. Now let's go ahead and call another function the input hex function. Now, by the way, these functions are part of the Komaneski library for Windows. I'll put a link to that in the description of the video, so you can go ahead and download those. There's also a link to a video on how to set them up. Pretty cool. And you can have the benefit of using those functions. Okay, so we'll do an input hex. Now, let's say they type an invalid hexadecimal value. Well, if they do, the carry flag is going to be set by my input hex function. So I'm going to say jump if carried input error. So if the carry flag is set, it's going to jump to the input error label, and input error label, and that was, where is that? Right here. That was this error display, and that will then jump back to the top of the loop. And we're going to test that in just a little while. Okay, so now what we want to do is we want to move that value. So I'm going to move that new value to the new value variable, because I want to save what they typed in, because when you do the input hex, it puts the value that the user typed in, the numeric value, into the RAX register, or EAX register if you're doing 32 with my functions. So we want to save that into that new value variable. And we need to do that anyway, because that's the way that the write functions work in Windows. All right, so let's go ahead and build it. All right, great. And let's run it to see if anything messy happens. Okay, so we're going to say position 1, that's 2222. Let's go ahead and enter a new value. I'm going to put an invalid number in. Oh, it gave me an invalid number. Okay, good, it works. So I'm going to go back to 1, and I'm going to type in a valid number. Let's put another invalid, -10. Great, so that function's working very well. Let's put a valid hexadecimal number. Looks great. So that little prompt is working just fine. All right, so we're done with number 2. We asked them to type the new value, and we put it into the new value variable. Okay, so the next thing we need to do is we need to position the read pointer into the new file. Now, we already did that code up above, but let's just go through it again. What I'm going to do is I'm going to move into RCX the file handle. This is the handle of the file that we opened. Oops, I forgot something. I forgot to tell you that we need to open the file for not just input now. We have to open it for input and output. So, oh my goodness, I completely forgot that. So what we're going to do is I'm going to scroll up to where we open the file, which is right here. And instead of opening the file with 8 and then 7 zeros, we opened it with C and then 7 zeros. Because if you take, so to open the file for both input, read, and write, input and output, you need to put in a 0C and then those 7 zeros. Is it 7 zeros or 8 zeros? I think it's 7 zeros. So that's generic read or generic write. So take a look at the comments in the description of this video, and I'll have that information in there, what each one of those are. So okay, so we did that. Sorry I missed that. We're back on track now. Okay, so we're going to put that file handle into RCX, the actual value in that variable. What else am I going to do? Okay, I'm going to move into RDX, that save file position. Now, what in the world is the save file position? Well, let's go back up here into the read area where we position the read pointer in the file. And did I actually save that in save file position? Oh, yeah, right here. So when we calculated the position in the file to move the read pointer, once we calculated it, I saved it. It was calculated within the RAX register. I saved it to a variable called save file position. And that's so I don't have to recalculate it all. Again, if I want to, I could just redo this code right here, both lines of the code. But instead of doing that, I saved it into a variable in the program. And now that's what we're doing here. We're copying it back into the RDX registers. We don't have to redo the multiply. Okay, so I'm going to move into R8 0. And let's put some comments in here. The file we wish to manipulate. The position to begin writing. And R8, I believe, this is the upper portion of the 128 bits that says how many bytes to move. RDX is the lower. R8 is the upper. And then we put a 0 in there because we don't have that big of a file. The reason why they have an upper and a lower is because you can have files that are absolutely huge. I mean, xenobytes in size, and you need 128 bits to actually store that large number. But we're not dealing with that large of a file, so we put 0 in R8. And then we're going to put into R9 0, and that's because we want to move the pointer from the beginning of the file. Okay, so then we'll say call set file pointer. Now, if you're doing this on 32-bit, you've got the exact same values, but you're not putting them in the registers, you're putting them into the invoke statement. So take a look at that in a previous video. Okay, let's go ahead and build it. Now let's run it just to make sure the program doesn't die with some strange error. Okay, looks good. All right, looks good. All right, so we're doing good here. Okay, so we got number 3. So we went ahead and positioned it. Now we don't know for sure if it positioned it yet. We're not going to know that until we test the data. Okay, so now let's go ahead and let's write. Now, by the way, I'm going to put a comment here. RAX will contain the position in the file where the pointer is located. So that's just a little reminder there for me to know that RAX contains that value if I want to save it. Okay, so we've got that done. Now, number 4 is now write the data. Now that you've moved the pointer to the location where you want to write the data, let's write the data. So we're going to move into RCX, the input file handle. Probably should have renamed that from input file handle to just maybe file handle or IO file handle, but that's okay. We're going to move into RDX, offset new value. Now the new value is the value the user typed in. We put that value into the variable new value, so that's the new value that's going to be written, and you need to send the address of that value to the function. Okay, so that goes into RDX. Then we're going to move into R8, the value H, or 8, sorry, which is the number of bytes. And because it's a quad word, it's 8 bytes. Let me see. Okay, the address of the data to write. Okay. And then we're going to move into R9. Let's go ahead and make this lined up. The offset of total written, because Windows requires a variable to store the total bytes actually written. So once the write file function is executed, it'll actually put into R9, or into the address that is in R9, it'll put that into the total written variable exactly how many bytes were written, so you can check that to make sure that the write occurred okay. All right, the last thing we want to do is we want to move a keyword starting at the address of RSP plus 32, 0, and we just don't use this. I think there's a couple of times that we've done that, and that's just a function, or that's just a variable or a value we don't use. And then I'm going to say call write file. Now what I want to do is I want to make absolutely sure that the data that was written correctly. So what I'm going to do is I'm going to compare RAX with 0. And this is going to check, see if the data was written. Okay. If it wasn't, I'm going to jump less than. So if it is less than 0, that means that there was a problem in the write. So I'm going to jump as if less than to error writing input file. And error writing input file is another little section of code right here where I simply display that there was a problem and the program ends. So that's what that's doing. And I believe that's pretty much the end of that code. Yep, I believe that is the end of the code. And then it jumps back up to read loop. So we can start it over again. All right, so let's go ahead and build this. All right, let's run it. Now I'm going to show you how to check to see if it's really written the values to the file. So I'm going to put a 1 there. Ah, okay. So position one, I believe it starts at position 0. So position 1 has 2222 in it. Let's go ahead and put something in A. Let's put all A's in there. Okay, program didn't die. Let's look at position 1 again. It's all A's. So we actually wrote the data out to the file. That's pretty cool. Let's change that back to 2. All right, great. Let's go to position 0. That's our first value. Let's put BBBB in there. Let's look at it again. And it updated it. That is so cool. Now let's go to position 50. So we're just move the read pointer or the IO pointer all the way to the middle. We display 36663 hexadecimal. And now we're going to move it back to the beginning of 36663 hexadecimal. And we're going to put in 1, 2, 3, 4. Let's look at 50 again. There's 1, 2, 3, 4. Let's go ahead and put in the original value. Oh, let's put in let's put in the original value. Now let's do something so I can show you that I'm not fooling you, that it's actually in the file. So I'm going to start at 0. I'm going to put in A. Let's do 1, B. Let's do 2, C. And let's do 99. And let's put ZZ. Oh, ZZ isn't a real hexadecimal, so let's put FFFF in there. Okay, let's leave the program. Alrighty, let's go ahead and find that binary file that we just updated. In Visual Studio, it puts it in a not too intuitive place. We're doing this random file writes project. I don't remember if it's an x64. I think it's up in here. There it is right there, the test file. So I'm going to right click on that and I'm going to say open it with my hex editor. And there's my AAAA. So this originally was 4 1s, now it's 8 A's. My second one was 4 2s, now it's 8 B's. My third one was 4 3s, now it's 8 C's. Let's go all the way to the bottom. And you can see our very last one is 8 F's. It was not 8 F's when we first looked at it. It was something like 3663 or something. Maybe I think that was the middle one. So that's pretty cool. So we've actually modified the file with a very small amount of code, because we've done it randomly. Okay, so that is random file IO. That's the last video that we're doing, or I'm doing, on this subject, unless some of you have suggestions for something else. You can do this with structures. You can do this with large amounts of data. As long as each piece of data is the same size, or each grouping of data is the same size, you can very easily move the read and write pointers around in the file and randomly read and write that data. Hope to see you at our next video.